So today we're talking about polynomials, and a polynomial has to be all of these things, and I just read it to the class, so anybody at home, you can read it to yourself. So which of these are polynomials? This is a polynomial. The hardest part is making sure that you know this part. The exponents have to be special. They can't be weird. They have to be whole numbers. They have to be, they can't have a variable in them, and they can't have negatives on them. So we were just talking about this one here. And what messes that one up? Why is that not a polynomial? The 3/4 in the exponent. Can't have a fraction in the exponent. Everything else is okay. All right. Now, I know a lot of people think this is not a polynomial because poly means many, and you're thinking that's got to have many parts, but that is a polynomial. It's okay. It doesn't have to have lots of parts. It can have just one term. It's a monomial. This is a trinomial. And this one isn't any kind of nomial because it's not a polynomial. It doesn't qualify. And what part messes it up? Yes. Drew. Yeah, that thing. And what's wrong with that? What rule does it break up here? Addition, subtraction, multiplication. There's no division in there. Right. And the other way you could say it is that this, I don't know if anybody in here is smart enough to know this, but that's the same as 7, or actually negative 7, x to the negative 1. Do you know how that puts the variable in the bottom, in the denominator? Does that ring a bell? All right, let's see if any of you can go farther with that. What if I had 8 over x? How could I write that with a variable with a negative exponent? 8x negative first. That's right. I thought you'd write that. Okay, so that's another reason you could say that this thing didn't qualify, because you could say that it has a negative exponent in it because of that part right there. All right, so moving on. Let's go to this. If you're talking about the degree of a polynomial, the degree is made up of the degree of the individual parts. So what's the degree of that one? You remember this? I'm not seeing a lot of recognition. All right, take that piece of paper I give you, flip it over to the back side. I'm going to give you a short power lesson on degree. You got to understand this before you move on. Let's say that I had 3xy, and x is to the third and y is to the second, plus 2x m to the third plus 15. Write that down. Now that is a trinomial. It's got 3 terms. But what's its degree? Well, first let's figure out the degree of each individual term. All right, so if I was going to look and see what degree this is, I would say, what degree is that? Well, the degree is made up of these guys, and they get added together. So this part, this term, has a degree of 5. This part right here, be careful now, it's not degree 3, what is it? Degree 4, because this is a 1 here and you add them together, it's degree 4. And this one, be careful, a lot of people think the wrong thing on this. What degree do you think that is? I'm hearing some zeros, hearing some ones. Think about it. Because it's not the degree on this number here, it's the degree on the exponent. This would be like having an x to the 0 here, so it's a degree 0. Okay, then what's the degree of the whole thing? Don't say 9. That's a common mistake. You'd think since you added these together that you just would add these together, but you don't. You pick whichever's bigger. So it's a degree 5 polynomial. Okay? All right, back to where we were. What's the degree of this one then? Well, the degree of the first term is 2. What's the degree of the next term? 1. What's the degree of this term? 0. What's the biggest one? So this is a degree 2. All right. Next. Let's just do some quick review here. And besides, I don't know if they'll be able to hear this at home on the recording, but I've got neato noises that go along with this. You know what this yellow thing is supposed to be? A balloon. What do you think the degree of this is? All right, now, here, listen for it. How about the degree of this one? Degree 4. You just find the biggest one, and that's it. There it is. Cool popping noises. I bet that goes over really big in like 2nd grade. What's the degree of that one? Right, and this one? All right. Next. End behavior is something that you have to understand, and I don't want you to think of it in terms of increasing or decreasing, because I just want you to think of this as like a rope. And one end's up, or both ends are up, or one end's down and one end's up. So just use up and down when you talk about end behavior. It's just the ends that matter. The stuff in the middle doesn't matter when it comes to end behavior. Okay, so this end of the rope is generally what? Up. And this end of the rope? Down. And which do you think we talk about first? The one on the left or the one on the right? The one on the left. Because we always read from left to right, and in graphs you do the same thing in a lot of ways. So remember that. Go from left to right. So this one I would simply say down, up. Because on the left it's down, and on the right it's up. Okay? And if I was really wanting to be careful, I'd say on the left it's down, and on the right it's up. But if I say them in the right order, I'll know that the one on the left is the first one I'm talking about. All right? How about this red graph over here? Up, up. Good. How about the blue graph? Down, down. And how about that fuchsia graph? Up, down. Okay. How about the green one? Down, up. And the blue one? Down, down. All right. I think you get the idea. Now, one thing that's kind of cool about that is that I'm going to teach you how to be able to tell, just by looking at the equation, whether or not it'll end up going up or down on the left and right. So you'll know how this thing looks just by looking at it. All right. Now I'm going to do it for this one, for example, and I'm not going to tell you what I'm using to figure it out, but then I'm going to have you give me a couple, and I'll tell you what the answer is, and hopefully somebody will be smart enough to figure this out, what I'm doing to figure out the end behavior. All right. So on this one, on the left side, I'm going to start on the right side. On the right side, it's going to be going down. And on the left side, it is also going down. All right, give me another one. Keep the numbers simple-ish so that you can check them on your graphing calculator. Actually, I'm going to pause for a second and have you check this one. Type that one into your graphing calculator and just verify that I'm right, that the ends both go down. All right, so somebody give me a different one to try. Y equals... Craigers. Give me one. Anything. Yep. Keep the numbers smallish, though. And these numbers, the powers are kind of the main thing to mess with.
Y equals negative 7x squared minus 6x plus.
All right. Now, my answer for that is it's exactly the same. It's down and down. Who thinks that they can change it somehow? Make it go like up and down, or up, make something go up, or I don't know. Make it different. Yes. Give me one. 3x cubed plus 4x minus 2. All right, that is definitely different. Now, on this one, on the right-hand side, it's going up. On the left-hand side, it's going down. Let's do one more and then see if you can infer from that what I am looking at each time. Somebody make me one that's different yet. Yes. Yes. On this one, the right side is up, and the left side is also up. Now, can you tell what I'm looking at? What do you think I'm looking at each time? Or is anybody telling me what I'm not looking at? What's kind of irrelevant? Yes, anything? All right, you're right that the last two terms are completely irrelevant. I don't need to know any of this. It doesn't matter a bit. Okay, so what does matter? We'll continue that on our next video.